Yep, that's okay. Recording's okay. So what is blockchain, meaning the space that's sort of evolved around this? And how does Encode Club help you guys transition in, right? So let's get started. What is Encode Club? So I'll kind of brush over this. It's the best place for Web3 education. So we've got loads of opportunities from education to boot camps to AMAs with the biggest people in the space. And our education sort of focuses on technical and non-technical learners. So there's a lot of space to get in. We've got building and investment opportunities. So we've got this great funnel with longer hackathons where we teach everybody everything that they need to know to build, get into the accelerators where we turn little startup projects into proper companies. And we have an investment portfolio that runs parallel to all of this to bring companies to the potential that they can be. We also have a jobs program that runs under all of this. So just by getting into our network, you're automatically considered for all of these exclusive technical and non-technical jobs. So something that's very surprising for people is that in the blockchain space, there's actually more non-technical jobs than technical jobs available. And the reason is we can have a ton of developers, but we need a lot of people around those developers to facilitate the company and do everything else that's not really programming work. So there's tons of opportunities sort of across the board. If you guys have any questions about that, please just punch them in the chat. I'll try to keep an eye on it as much as possible. Oh no, I've lost the chat. Okay, well, I'll try. Everything we do is free, global, and virtual. Free, no impediment, especially for students. Global, you can tune in from anywhere. If you got an internet connection, and virtual, you don't have to be anywhere. You can be right in your room tuning in. So it's a pretty sweet deal. If you're not sure where to start, talk to us. So I'm gonna put a form here. So you can check this out through the chat, or you can scan that QR code. And what it's going to do is going to take you to a form where you can punch in some of your information, sign up to our mailing list if you want to be the first to know about certain events. And you can also apply to talk to us in a one-on-one call. So we'll try to understand your goals as best we can and try to understand how we can best achieve those goals with you, right? So I'll give you a second if you want to scan that QR code. I'm going to try to get the chat back up so I can punch that back in. Maybe I need to stop and restart. Oh, we've got way more. Okay. Hi, everyone. Just something I said at the beginning of the talk, please feel free to use the chat. Don't be scared of putting up the wrong answer. That's totally fine. We're all here to learn together. Okay, there it is. Okay, so I'm going to punch that into the chat. Right. I'm also going to turn off the heater in my room because it's quite hot. Right, so that's the URL. If you feel like you like what's going on in this talk, go ahead and fill out that link. You can scan the QR code. Let's get started with the rest. So what we're going to start with now is what is a blockchain, meaning what is the technology that we're talking about here? Right, what is a blockchain? So we're going to be going over these things, these 11 concepts, and do not let these intimidate you. They're very big words like cryptographic and decentralized and stuff that you might not know yet, but these are actually very simple concepts with complicated names to them. So don't worry about it. This is more a slide to give you confidence because you're going to be a pro at all of these things by the end of this talk. So the first thing we'll be talking about is cryptographic hash functions. So this is the hardest thing today. Seems like a lot, but if you can nail this, you'll nail the rest. So who here, man, I can't get the chat. Who here has taken algebra at school? Should have been pre-university. Should just punch them in the chat. Raised hand, yeah, good. Okay, that works too. I hope it's all of you. I'd be very impressed if you made it to university without having to do algebra at least once. Okay, you know what I'll do? I'll keep the chat and these slides different. So you will be able to see those, but just ignore them and keep an eye on this. So yeah, everybody's taken algebra. So you'll remember the linear functions that we had from algebra, right? So in algebra, we had an input and an output, and that's what a function is. We can take multiple inputs, but with a linear function, we use one input, and that's our x. So we go from x to y. So if we take the linear function, y equals 2x, we take all those x's, we double them, and we turn them into y's as our output, right? So we can see 0, 0, 1, 2, 2, 4. I hope this is just review for everybody at this point. So we're pretty solid, right? We're going to move on to a different kind of function today. And so as we remember, linear functions have the input of X and the output of Y. We're going to talk about cryptographic hash function. And so the input of a cryptographic hash function are messages, transaction, keys, this other thing called nonces that we'll talk about, right? Don't let these words scare you. You're going to know all of these by the end of the talk, but just know that we have inputs and outputs the same way you do with a linear function. So this should be pretty familiar. The output of a cryptographic hash function is a 256-bit hash, right? What does that mean? Well, let's look at this in practice and we'll dissect it from there. So I've showed you two sets of pairs. So similar to what we saw in the linear function, we saw 1 and 2 and 2 and 4. This is another set of pairs, right? So we've got hello world and we've got 730 and this whole jumbled mess after. And we've got hello world with a period and we've got another jumbled mess, but a different jumbled mess, right? So what are we seeing here? Well, we have an input and our output. The hash is a set of letters and numbers all kind of jumbled up together. And what we can see is we change this little thing here. We just put a period in and these are totally different. Guys, so I see you're raising hands. If you have a question, please just drop it in the chat because that'll be a lot easier for me. And I can keep on top of that a little better. So hello world with a period returns 730 and things seem pretty random. There is a bad in there, but I don't think that's intentional. So this looks random. And hello world gives us 619 and a bunch and looks random again. So what's going on here? Well, we call this a 256-bit hash. And the reason we call it that is because there are 2 to the 256 possible outputs. So if you remember, 2 squared is 4, 2 cubed is 8. We have 2 to the 256 outputs, which is just an absurd number, right? So we talk millions, billions, trillions, and then we just kind of lose count from there. So lots of different outputs. And the strength of this function is that things look random, but they're not actually, right? So if we look back at our linear function, every time I plug 1 into this function, I'm going to get a 2, right? Every time, without fail. If I plug a 2 in and I get a 4 on Wednesday, I should get a 4 again on Friday. That's just how the function works, right? So things look random, but they're not actually. The strength of that is if I have an output, right? And if I have the 730 mess, I have no way of knowing that the input was actually hello world. Same with this. There's nothing I can reverse engineer to figure out those inputs from there, right? So this comes out pretty strong, right? So it's not random, but it looks random. And so these are the overall properties of this function. We see that a same input always results in the same output. It's extremely hard to reverse and engineer. And even a tiny change to the input results in a very large change to the output. All we did was add a period in there and it totally changed things. Okay, so these are the 3 things, and this is why cryptography is going to help us out a lot today. Is everybody with me? Does anybody have any questions about that? Please drop them in the chat. If you're with me so far, good job. That was the hardest thing we have to learn today. So if you got that, we're solid on everything else. So I don't see any questions in the chat. We'll move on. Let's talk about donuts. So my favorite donut doesn't even have a hole in it. It's a Boston cream donut. I don't know if it's outside the US, but it's one of those ones with filling in them. They're very good. And so in high school a lot, there's a Dunkin' Donuts donut store near our school. And so my friends and I used to get each other donuts in the morning, but we're not really the gift giving type. We're not nice like that. So we sort of kept record like, okay, I'll get you donuts, but you're going to have to give me that $2 later. So what is a good way? Let's say Anupam and my best friend Beaumont, we are getting donuts for each other in the morning and we get this before school. What's a good way for us to record all of these transactions, all of these donut runs for each other so that at the end of the month, we can pay each other back? So I'll give you a second in the chat. Where can we write these things down maybe? Sandra, any ideas? Where can we write this? On a book? That's a good one. Yeah. Excel spreadsheet, that's a good one too. Good. Okay, so we have a couple different ways we can do this. What's the most efficient way to do it. So let's say we do it on a book or an Excel spreadsheet. Should we pay each other every time, or is there something else we can do to make things a little simpler so we don't always have to be paying each other? Okay, well, here's my idea, right? Let's say, and let's see it. So I owe Beaumont $5 for the pizza he got me, and I owe him another $7 for the donuts he got me. Maybe he got me a few donuts. Beaumont got me, no, I got him pretzels. So he owes me $4, something like that. And so I owe him $2. We get stuff for each other, right? So let's write this all down and let's add this all up. So if you think about it, right, if I owe him some and he owes me, and it's just us, if we add this all together, by the end of the month, one of us is going to owe the other more than the other. One of us is going to owe one more than the other. There it is, right? So after all of this, even though I owe him for this and he owes me for this, at the end of the month, I owe him $10. I hope that makes sense for everybody. If it doesn't, please just jump it in the chat, right? So we're just working with two people here. I'm working with my best bud, Beaumont, right? So Anupam and Beaumont are transacting between each other. And let's say we put it on a notebook. We're not very tech savvy just yet. So we put it in a notebook like that one, right? So where are we at now? We have a central ledger. A ledger is just something that records transactions. And so we're using a notebook at this point. And this central ledger is capable of recording transactions between two parties, so me and Beaumont, who trust each other, we're best buds, who will settle at the end of the month, right? Just to keep things simple and we don't have to always be moving money between each other. Now, it's a good system, but what happens when our other friends want to join, right? So my other friends, Eric and Atharv, here we're going to be talking about Charlie and Damir because it's just a little easier. What if we introduce more people into this? So we get the whole squad involved, right? So, okay, that's fine. We're now transacting between four parties, A, B, C, and D. And so we write this all down. And so I have to pay Charlie 6 and Damir has to pay Beaumont 2 and so on. And so we add this all up. And at the end of the month, we get a little bit more complicated of a settlement, but same principle, right? Some of us owe others more and some of us are owed money by others. Pretty simple, right? And this is kind of complicated. We can't be passing a notebook between each other all the time, right? What if we make transactions? So let's put this all on a website, right? So we can all log onto the website and do this thing. So where we're at now, we have a central ledger, which is the website, which is capable of recording transactions between multiple parties who trust each other, and we're going to settle at the end of the month. What if we don't trust each other? So there are quite a few people at my school where they're all right, but I just didn't know them, right? So I don't know if they're going to mess something up on the ledger, and I don't know if they're going to put in a fake thing and say I owe them something when I don't. So what do we do if we don't trust each other, right? Well, let's just all sign our transactions. That's pretty simple, right? So if I am saying I'm going to pay Charlie 6, I just sign my name next to it. If Damir is going to pay Beaumont, he signs Damir, Beaumont, Anupam, and we come to a settlement. Things seem okay. What's the problem with this? Does everybody have any idea? What might go wrong, right? Signatures are pretty strong, but where might the flaw be? Forgery, fantastic, right? So especially, my signature doesn't look like this, but like, let's say it did, it'd be pretty simple. All you have to do is really slant the letters. It'd be pretty simple to copy the signature, right? And over time, if I was devious enough, I could learn this. I could figure this out. So what can we do instead? Right? Well, our current stage is that we have that central ledger website that records transactions between multiple parties. We don't need to trust each other because we have a mechanism and we settle at the end of the month. All of our transactions have to be signed, but it's not a perfect system. We can forge each other's signatures. So to fix this, we're going to dip back into cryptography, the stuff that we just learned, right? So we have new inputs. Every user is going to be assigned a secret key and a public key. So all four of us, A, B, C, and D. I have a secret key and a public key. Beaumont has a secret key and a public key. Everybody knows my public key. Anupam's public key, everybody knows. Nobody knows my secret key except me, right? So only the user knows their secret key. Public key, everybody knows. Let me know if that's confusing. Just punch it in the chat. Please feel free, right? So we got secret keys and public keys. So what we're going to do now is, if you remember our linear functions, we had an input of X and Y, our signature function and our verification function. These are two new functions that we're going to introduce, and these are going to be cryptographic functions. So multiple inputs and some kind of hash output. Right, so for our signature function, we're going to take the message. The message is something like Anupam pays Beaumont $50. And I'm going to assign my secret key. So if I have to pay him, my secret key needs to be on that. Remember, nobody knows my secret key. And so if I do that, it's going to return a signature hash. If you remember, the hash is a string of letters and numbers all together. Looks random, not actually. We went over that. The verification function is going to tell everybody else, is that signature legitimate? So remember, that signature looks totally random. So if Charlie is like, I don't know if Anupam actually paid Beaumont, he's going to look there, but it's going to be tough for him to figure out because it's just going to be a bunch of numbers and letters that he can't really make sense out of. So this is where the verification function helps us out. We have the message, Anupam pays Beaumont $50, the signature hash that was returned as the output before, and my public key. Damir knows my public key, he knows the message, and he knows the signature hash. These things are public. So he can run this all through the verification function. And the verification function is going to tell him true or false. True meaning, yes, that was his signature. You're all good and that's legitimate. Or false meaning, hey, that was a forged signature. That's not a real signature, right? Everybody with me so far? Just let me know if you're not, right? So we have a way of signing these transactions and checking that they've actually been signed, right? Which is quite good, right? So here are the properties of digital signatures that we have now. We have a signature function, which is a cryptographic secure way to attest a transaction. So to say like, yes, I actually did want to pay Beaumont $50. And we have a verification function. So everybody else on the network in our little posse can check to see whether signatures are legitimate, right? So where are we now? We have a central trustless ledger. We don't have to trust each other because we have ways of checking each other. So our website records transactions between multiple parties who are going to settle at the end of the month. All of our transactions must be digitally signed. Okay, so we seem okay so far. But what if the same signature is applied to an identical transaction, right? What might this look like? So let's say I pay $50 to Beaumont and there's my signature. And Beaumont's like, I really like getting paid $50 by Anupam. So he says, let me just copy that. Let me just copy paste it on our website a little bit. And he's got my signature, right? So it looks like I've actually done it. And so for the signature functions purposes, it looks at the message, it looks at the signature, it looks at my public key, and it says, yeah, that's legitimate. We're all good, but that's a problem, right? Maybe I only want to pay him once. So what can I do? Anybody have any ideas? There is a big hint at the top of the slide. But does anybody have any ideas on how we can fix that problem? Give it a second. Okay, well, let's say we assign a unique transaction ID to every transaction. So let's look at it now, right? Anupam pays $50 to be that transaction. We're gonna give this ID 60E, whatever, right? And the next time I pay him, it's gonna be a totally different transaction, right? So you remember our cryptographic functions, right? Every time we change the input, every time we add a period to hello world, our output totally changes. So if we change this message even a little bit, which is what that transaction ID is going to do, our output totally changes, different signature. So if he tries to copy this signature onto the next one, the verification function is going to tell us that, hey, that's illegitimate. That's not a real transaction, right? Everybody with me so far? So we imbue all of these transactions with transaction IDs. That becomes part of the message. We're all good. Okay. Let me know if anybody's confused on that. Please don't be embarrassed. Just go for it. We're here to learn. Okay. So where do we end up? We have a central trustless ledger website, which records transactions between multiple parties who are going to settle at the end of the month. All of our transactions are authenticated with digital signatures. So we're all good. How do we make sure people actually settle though? So we have all this written down and the end of the month comes and I'm like, Damir, you owe me $44. And he's like, I'll get it to you next week. But I'm sure we all have known those kind of people at school. They just never really get it to you, do they? Right. So anybody have any ideas? How can we make sure that people actually settle at the end of the month without having to rough them up to get the money? Reference. Yeah, that's a decent idea. But what we're trying to do here is cut trust out of the system. Reference that presents the transaction. It's not a bad idea. That is a solid idea. What we're hoping to do is remove any need to trust. So if somebody has a reference, then I'd still have to trust that reference and believe that they're not just a paid actor or something like that, right? But very good proposal. What we'll do instead is we will make sure that there is a certain amount of money in the pot already. So if you want to be part of our donut runs, fine, but you got to put $150 in first, right? So you got to put money in first. You're only allowed to spend as much as you put in. Overspent transactions are invalid. So for example, if I put $150 into the system, I pay Beaumont $100, I pay Damir $50. When I get to Charlie and I try to pay her $20, the system is going to say, oh, nope, you can't do that, right? You don't have enough money to spend here. So no overspending, that's a rule we put in here. So what are the properties of this? There's always money to move. And as a nice little caveat, we never actually have to cash out. If we put some money into the system and we never exceed that limit, theoretically, I could go the entire school year without ever having to worry about putting cash in or taking cash out. I can just kind of keep it in the system, which is nice, right? So there's always money to move and we never really have to cash out. We can use currency within the system. Here's the issue. One of us is going to have to, sorry. Yep, just my brother. So what are the properties here? So how do we make this happen without human attention? That's the issue, right? So one of us is going to have to look at the ledger and say, hey, Damir, you only put $100 in there. You're not allowed to spend more than that, which might be okay if it's just me and my bud Beaumont, but especially as we add more and more people to the system, that gets quite difficult, right? So how do we make this happen without human attention, right? So we're going to use smart contracts. So some of you who have heard this term before, right, have a guess. What does it mean in the chat? Or if you haven't heard this term before, just take a guess and ignore the slide. What is a smart contract? No takers? I guess it manages the transaction of the people who are involved in the system. Yeah, it does. So if we think about a real contract, right, it will take care of the payment automatically. Yes. Okay. So smart contracts are a silly term that I can tell a lawyer did not come up with. That it monitors each and everyone's payment. Yeah, kind of. So smart contracts, don't think legal contracts. Smart contracts are this, right? They take a cause and they execute an effect, right? So I say, if the transaction is listed that I pay Beaumont $50, then move $50 from my account to Beaumont's. Very simple. If, then, right? If I study for this test, then get me an A on the test, that sort of thing, right? And what's really nice about this is we can put this completely in code, right? So we don't need anybody to monitor, right? We can have the system completely do this for us. So what's nice about this? It's fully in code and it operates automatically. We don't need people. We don't need trust, right? So where does this end up? We have a central trustless ledger, the website, which records transactions between multiple parties who are going to automatically settle at the end of the month. And all of these transactions are authenticated with digital signatures. Here's the issue. Who controls and maintains the ledger, right? So how can we make sure that, because we're not all going to monitor the website, and that might be kind of difficult. Blockchain, that's a good, yeah, good guess. But how specifically, right? So let's take this in steps. What we could do is, rather than having one website and one set of credentials and just kind of trust everybody, let's give everybody their own copy of the ledger, right? So I've got a notebook, Beaumont's got a notepad, Charlie's got a diary or something, and Damir's got a notebook as well. Everybody has their own copy, and transactions are going to be broadcast for everybody to record, right? So I'm going to say, hey, everybody, I paid Beaumont $50, write it down, right? So we can all keep track. So no one person has to keep track of this. This is good. So it seems like we're okay, but what's an issue with this system? Does anybody see a problem here? This spoon is killing me. Nobody sees a problem? That's okay. Well, what if someone didn't declare? Perfect, right? What if somebody doesn't declare their transaction? So let's look at the stage right that we're at. We have a decentralized ledger. What that means is we don't have it in one place anymore, that website. That's important because what if that website goes down one day? Can't do anything, right? But our notebooks can't go down. We have 4 of them. Even if one of us loses the notebook, we've got 3 other copies. So that's kind of nice. We have a decentralized ledger. We have ledgers, actually. They record transactions between multiple parties who are going to automatically settle at the end of the month. All of our transactions are authenticated with digital signatures. But at this point, how do we know which ledger to trust, right? It's just like Lee said, what if somebody doesn't declare their transaction, right? What if I'm feeling like, I don't really want to write down that somebody paid me because I want to press them for it later and I want to double charge them. Or Charlie's feeling a little bit lazy that day and she thinks, I'll write it down and she forgets and we don't have an accurate ledger, right? So to solve this, we're going to dip back into cryptography. So you guys should be pros by now. Remember, the linear function goes from X to Y. We use the signature and verification functions to help us with the digital signatures. Same thing here. This is the last function we're going to talk about. And it's a proof of work function. The proof of work function is going to use 2 inputs, right? The first is the transaction, meaning Anupam paid $50 to Beaumont with that unique transaction ID, remember from before. And it's going to use something called a nonce, right? Keep in mind the transaction, just wanted to make sure that also includes the signature. So it's like everything. It's the transaction ID, it's the signature, it's the message. And then we have this nonce. I'll explain what a nonce is, don't worry about it yet. But we have these 2 things in play, and this returns a proof of work hash, right? So we don't know what proof of work is yet, but we know that it's a hash, and we remember what a hash is. Does somebody put in the chat, what is a hash? We've gone over it a couple times. Come on, guys, I believe in you. What is a hash? Random generated code. Yeah, very close, right? So what we remember from what we saw with the Hello World stuff was it's not actually random, right? It looks random. That's the key. It looks totally random, but it's not actually random, right? So it's powerful in that. It's a bunch of letters and numbers. Oh, hi, Arjun. So we have letters and numbers together in a string that looks random, but it's not actually, right? And we have 2 to the 256 different possibilities. It's very strong. It's very hard to crack, right? Let's look at proof of work. So a nonce is a special number that satisfies the challenge that we've set. And so what does that mean? Let's say our challenge is find a nonce input that returns a hash that starts with a certain amount of zeros, right? So for example, find a nonce. So SHA-256, don't let that confuse you. That's a common cryptographic function that's used for banks and for websites and stuff like that. And we're going to put the message, like we talked about, the transaction with the nonce, and find me a hash that starts with 30 zeros. So somebody tell me, give me that number. Give me a nonce that gives A pays 50 to Beaumont, right? Give me that transaction plus a nonce and give me a hash that starts with 30 zeros, or give me the nonce that makes it start with 30 zeros. This is kind of a mean question because it's not something you can do, right? So users on the network, which we'll call them nodes, they have to guess and check through 2 to the 256 possibilities. If you remember, that's just a hard, absurd number. It's not something humans can even do. We'd have to get our computers to do it for us, right? So we have the transaction, we plug in a nonce, right? We don't know that nonce. So the only way we can do this is just to guess and check. Try a bunch of nonces, see what works, right? The hash will be about 256. Yeah. So we have 2 to the 256 different possibilities there. Very good. Right. So proof of work is users competing to find a nonce that's going to meet the network's requirements. So the example that we looked at is the network requires a hash to have 30 zeros at the beginning of it. The set of transactions, which we'll call a ledger now, with the most computational work, meaning the most nonces found, is trusted, right? I'll say that again. Users are going to compete to find that special number that meets the requirement. So it might be 30 zeros in the beginning, it might be something else, right? The set of transactions, which we'll call a ledger, with the most computational work, meaning the most trials of this, people have done this the most on that chain, is the one that's going to be trusted, right? If anybody has a problem with that, please punch it in the chat and I'll explain, right? Where does this end up? Well, we have proof of work that's difficult to achieve, right? It's not something, I just asked you guys that. I didn't hear anything for about 10 seconds. I could give you the rest of the day and you still wouldn't be able to find it. I could give you the rest of the year and you probably have a hard time finding it, right? So we need computers to guess through lots of combos. We need them to run this for us. And the great thing here, and a kind of common theme in cryptography, is that it's easy to verify, right? So as soon as I figure this out, let's say A, B, C, and D, Anupam, Beaumont, Charlie, and Damir are all like, okay, we got to find that proof of work. And I figure it out. And Beaumont doesn't trust me. He says, well, I think he kind of fibbed that nonce a little bit. He can check it for himself. He can plug that nonce in and see, does that returning hash have 30 zeros at the beginning of it? It's very easy to verify, but difficult to achieve. So what does this look like? Well, let's start collecting our transactions. So Anupam pays 50 to Beaumont, Charlie pays 20 to Damir. Let's pay this, put this all into a block, right? And the block is only going to be complete if we have this proof of work done. If we can say that I found a nonce that when we take everything here, the transactions and their IDs and their signatures, everything in this block returns a hash with 30 zeros at the beginning of it, right? Only then do we say that the block is all good. This other block on the right has transactions. We don't have a proof of work. If it doesn't have the proof of work, we don't care about it. It's like it didn't happen. We're only concerned with the ones that have proof of work at the end of it. Hope everybody's with me. If you're not, punch it in the chat. So we're going to start collecting transactions here, and blocks are completed with their proof of work. Where does this get us? Well, it gets us to something very exciting, which is a consensus mechanism, right? So that consensus means our way of agreeing about things. So when it was just me and my buddy Beaumont, we're best friends, we kind of trust each other, right? So if he says I owe him $4, yeah, I owe him $4. He has no reason to mess with me. But as we start expanding this network, it gets harder and harder. We can't just take each other on our words anymore. So we need a way of all agreeing that, yes, this is the thing that happened, even if I don't trust the people I'm working with. So the chain, the ledger, with the most proof of work is trusted. And what's great about this is it doesn't require any intermediaries or third parties. The code can do everything. So we have a way of all reaching agreement without trusting each other and without needing a broker in the middle. This is great, and I'll explain why a little later in the talk, right? So as an example, this is some very difficult math, and so it might be a challenge. If I have 4 sets of proof of work, and Beaumont's ledger has 2 sets of proof of work, who are we going to trust? Whose chain of blocks do we trust? May need to crack out the calculators for this one. 4 sets. Yeah, good, right? Very quick, right? The one with more is the one that we trust. Pretty straightforward. Yep, yours, of course, yes. Okay, so where does this end up with? I've got a decentralized ledger. I'm going to say this a whole lot. Records transactions between multiple parties who are going to automatically settle at the end of the month. All of the transactions are authenticated with digital signatures. And now we have decentralized consensus as to the correct record. We have a way of agreeing in a decentralized way and in a trustless way. This is very good, right? But all I've shown you so far is that we can agree that this block is good and this block is not, right? The one on the left is good, the one on the right is not. But what stops somebody from, let's say we have block 1, 2, and 3, from taking block 4 and putting it in the beginning, right? Maybe Beaumont is feeling a little devious and he thinks, actually, I want people to think that this transaction happened earlier than it actually did. Anybody have any ideas? How can we stop this from happening? How can we stop blocks from being reordered? Anybody have any ideas? Wild guesses are totally okay. Timestamps, that's a very good one. So timestamps would be good. we're going to do something pretty similar because the issue is the transactions might have happened within fractions of milliseconds of each other. So that gets a little tough, right? Like which one happened before which, maybe this one went into this block and the other went into another block, right? But timestamps is a very good guess. Okay, so what we're gonna do is involve a little bit of cryptography again. And we're gonna say that block 2 has to have block 1's hash. So you remember with the proof of work function, we started with inputs, cryptography hashing. Yeah, exactly. So we had inputs and we return a hash, right? So it looks like the hello world thing. We have some inputs and we return some random letters and numbers and stuff. It's a mess. And so each of these blocks is going to be finished off with that proof of work. That's what we agreed is our consensus mechanism, right? What we'll say is, okay, if you want to have block 2 has to have block 1's proof of work hash at the beginning. And if you want to have block 3, it has to have block 2's hash in the beginning. Everybody with me? Please let me know if you're not, right? So in this way, you remember the way that cryptographic functions work is even if we change a tiny thing to the input, the output is going to totally change. So the proof of work for block 2 is going to fully depend on everything that we see above it, meaning this hash is also going to factor into that equation. So if we were to change this hash, it would change our proof of work. So we have a very easily verifiable way of seeing whether these blocks are in the right order. If I want to see whether this should be 1, 2, 3, I check. Okay, does this hash match this one? Does this hash match this one? We should be good. Hash match, that's a tongue twister a little bit. So when we do that, block order is maintained and a change to the hash changes the entire proof of work. So we have a way of checking. How do we get to know if the first transaction is legit? So good question. When we start, that original proof of work is kind of an essential block and we can't test it as much, but remember, we have signature functions that tell us that every transaction was legit. We have the verification function to check, right? And everybody has to perform proof of work on this. So that first block, whoever runs the proof of work is going to have to check themselves and say, yes, this actually happened, right? And so what we can do is we can limit the amount of transactions in the first block and expand it later, just to make sure that we're a little more careful about that first block. Typically, if you start your own blockchain, right? If you have your own network, this will be a problem for you. Most likely you'll be using somebody else's. And if somebody else has a blockchain that you can use, chances are we've have 50, 100, thousands of blocks already on it. So it's not something we have to worry about, but very good question. A change to the hash is going to change the entire proof of work. So we have a couple ways of knowing whether something's been tampered with here. Sounds good. So where does this end up? Again, if anybody has any questions, just punch them in the chat. You guys have been great for that so far. Our decentralized ledger records transactions between multiple parties who are going to automatically settle at the end of the month. You guys are going to be pros at this. All transactions are authenticated with digital signatures, and we have decentralized consensus as to the correct record and its order, right? Not just that the blocks are good, but they're supposed to be in that order. We're good. This takes a lot of effort, figuring out proof of work, because I have to guess through 2 to the 256 different possibilities, right? So how do we incentivize people to do proof of work? Especially if I'm running this through a computer, this takes a lot of energy. That might cost quite a bit. And if I want to compete better than everybody else on the network, I might have to invest in some pretty solid equipment and stuff like that. So how do we get people to do proof of work? Does anybody have any ideas? I'm going to hide that slide so I don't give away the answer. Does anybody have any ideas? How can we encourage people to actually maintain this network and keep the blocks going? Miners rewards, very good, right? They can be offered coins. You guys are solid, right? So what can we do? Let's create cryptocurrency, right? So we're going to imbue this within the system, and miners are going to listen for transactions, right? So they're going to listen out every time I say I paid Beaumont $50. They're going to create those blocks, do the proof of work, and they're going to let everybody know, like, hey, I just made a block, seems legit, put it on the ledger, right? So miners are going to compete with each other to complete proof of work first. And the people who achieve a proof of work are going to be rewarded with cryptocurrency, right? And this is really good because, okay, when it's just me and my buddies and we're getting pizza for each other and stuff, it's not too bad. When we start involving the entire school or the entire state or country in this, it's going to be a lot of transactions that we have to listen to. So it's going to be a lot simpler for us to listen to blocks rather than all of those little transactions within them. Listening for blocks, not too bad, right? So I'll say that again, we're going to compete with each other. The person who achieves this, the person who figures out the nonce and is able to achieve the proof of work, which is not an easy thing to do, you got to guess through a whole lot, they get the reward, which is cryptocurrency. This is where cryptocurrency originates from, right? It's a reward for miners, people who maintain the network for everybody else. So where do we end up with? Again, questions in the chat, please do. Our decentralized ledger records transactions between multiple parties who will automatically settle at the end of the month. All of our transactions are authenticated with digital signatures. We have decentralized consensus as to the correct record and its order, and continuous maintenance of the network is incentivized and encouraged when we reward miners with cryptocurrency. This is kind of most of it. This is almost everything about a blockchain that we've learned. So we have a way of ensuring the security. We know that the transactions are legit, the blocks are legit, the order's legit, and we have a way of all making this happen. We can reward the people who help us out with this. So let's try to crack it. What might be a problem? That's a main question. Is this secure? Let's ask everybody. So how secure is this? Really secure? Let's say on a, I don't know, on a scale. Like, can anybody come up with something that might break this system? Or does it seem secure? Does it seem okay? Looks solid. I like that. Yeah, looks pretty solid to me too. But like, let's have an example, right? Let's try to see if we can break this, right? Hashing and immutable it is. Yeah, very good. So let's do a quick review, and this will be a nice summary of everything we've learned. So cryptographic functions ensure that the transactions and their order are authenticated. So we do that with the signature function and including the hashes on each block. We also have a way of checking the authenticity of all this. So I don't have to take anybody's word for this. I don't have to trust anybody. Maybe Beaumont and I got in a fight, and I don't know what he's going to do, right? So I can check this. And I do it with verification functions, and I can plug in the nonce. So there's a way of checking each other. So we don't need trust. Only the chain with the most proof of work is trusted. This is our consensus mechanism. So as the network grows, cheating this system gets more and more difficult. Why? Remember, we're competing with each other, right? So if I want to, let's say, create a fraudulent block and do a fraudulent proof of work, I not only have to create that fraudulent block and do all of that, I also have to outpace everybody else on the network and get my block on there first, right? So if I try to make a chain and I'm not able to do it in time and everybody else outpaces me, and so the real chain has 7 blocks and mine only has 2, who are they going to believe? The 7 block one, right? So let's look at an example. I hate B. So we get into a fight. Maybe he gets me the wrong kind of donut. He doesn't get me the Boston cream I like. And so I broadcast, I pay $40 to B, and I broadcast that to him, but I don't broadcast it to anybody else because I want Beaumont to think that I paid him $40, but I don't want to have actually paid him. So I want him to have his own fraudulent chain, but I don't actually want to pay him, right? What would I have to do to pull this off? Any ideas in the chat? Anything. What could I do? Or is it just impossible? Can I not do this? I will say there is a way. There's one small way, but it might be kind of tough. Okay, well, let's think about it, right? So only the chain with the most proof of work is trusted. That's what we all agreed, right? So to do this, to make a fake chain for Beaumont, I would have to create my own proof of work on this fraudulent chain in order for Beaumont to believe that it was the right one, right? So I'd have to create these transactions, I have to do the proof of work, Quite a hefty process, right? Because this is not as easy as solving a math equation on my desk and putting it up. This is so many combinations, right? 2 to the 256, right? So it is possible if I have 51% of the computational power on the network. Yes, if I can get 51% degree, very good, right? So if I or a coalition of other fraudulent, devious people who hate Beaumont have more than half of the networking power, then I can pull this off. It's possible. It's not guaranteed, but it is possible. So let's say, right, we've got 4 of us, A, B, C, D, and A, C, and D, Anupam, Charlie, and Damir, we all agree that we just can't stand Beaumont and we're going to mess with them, right? So it is possible, but let's say we get the school involved, and let's say we get the country involved and the global network, just something very, very huge. This becomes pretty difficult, right? Even if we have 1 million people, right? I would have to get, let's say we all have equal computational power, I would have to get 500,000 other people other than me to all say, yes, let's mess with everybody else, right? And we'd know if anybody checked this, they'd be able to go through and they'd say, hey, that's not a real thing, right? So as the network grows, it just becomes way, way more difficult, borderline impossible, right? So the blockchain's strength here is in the cryptography, but it's also in its size, right? As a blockchain grows in its network and the nodes available, it becomes even more secure. Okay, I've noticed we've come up on the hour, but don't worry, I don't have too much stuff. We'll probably go for another like 15 or so. I hope everyone doesn't mind. So let's look at another example, right? So this one I'm kind of outmatched. Let's say Charlie doesn't like the set of transactions that's happened and she wants to go back a couple blocks and remove records of people paying her. Why? Maybe she wants to press them for it later and say that, actually, you never paid me, so she can get more money. What would she have to do here, right? Well, let's remember every block has the previous block hash. So this is how we link everything together, make sure the order is fine. So to change block 6, let's say she's having a trouble with block 6 and she says, let's change everything. She has to redo the proof of work for blocks 1 through 5. Not only that, and outpace the real chain in doing so, right? So you remember, we're kind of working with one real chain. We have a fake chain over here, right? So she would have to go back all the way while this one is still going. So somehow she would have to redo all these blocks, catch up, and outpace everybody with nobody noticing, right? So again, in theory, this is possible. You could do this, but practically it's basically impossible, right? It was just too much power to compete against, and it's very, very difficult. So possible, but extremely difficult. And also, she doesn't have other people's secret keys. She doesn't have my secret key or Beaumont's or Damir's, so she can't fake transactions here. Otherwise, we'll know immediately because we have that verification function, right? So she can only make transactions that pertain to her. She can only pay other people, right? So that's not as great for her. If she wants people to pay her, it's going to be a pretty bad solution for her to just start paying everybody else just to change. And we'd know very quickly. So where does this end up? I'm going to not repeat all of that. I think you guys are good so far. Please let me know if any of that is confusing. And so where we end up is our system is extremely secure, and it becomes secure even more as more people join our network, right? As more nodes, people. So what is a blockchain? A blockchain is this, a decentralized ledger, I am going to say it, decentralized ledger that records transactions between multiple parties who are going to automatically settle at the end of the month, where all the transactions are authenticated with digital signatures, and we have decentralized consensus as to the correct record and its order, and we have continuous maintenance of the network that's encouraged with crypto rewards for our miners. In simple terms, there are 5 things that make a blockchain. We have a trustless ledger of transactions that's immutable. You cannot change this because, as we looked at, if I want to change block 6, I got to change everything else before it. More likely, this blockchain's been running for a while. So if I have to change block 1024, I got to change 1023 blocks before it and outpace the real chain. So it can't be changed. We can't fake transactions either because of our cryptography. We have decentralized. It's failure tolerant, meaning if we have one server that's centralized and that server fails, network's done, right? We have to wait for that server to come back up. But if one of our nodes goes down, that's okay. We probably have hundreds more, right? So we're failure tolerant, we're user controlled. All of us are taking part in the system, right? Anybody can be a miner if they want to be, right? So we're all user controlled. And it's also transparent, right? We know everything that is happening on this blockchain because we can access it. And we can see, oh, Anupam paid $50 to Beaumont, cool. right? It's secure. We use cryptography, we use hashing, everything is secure. It's distributed. It's quicker because we don't have to go through anybody else. We don't have to trust each other. So I don't need safeguards in place, right? I can always check everybody and I'll know as soon as they've done something that's fraudulent. So this is quicker, it costs less. And consensus, there's no need for trust. So that's kind of a review of everything else that we've done. We have this trustless ledger of transactions that's immutable, decentralized, secure, distributed, and provides consensus. So I hope that all makes sense. What we've just talked about when we've gone from donut runs to all this cryptography, everything, we've just learned what Bitcoin is. Bitcoin is the original blockchain, and this is where all these ideas come from, right? Bitcoin, as the cryptocurrency, is the reward for miners on that system. So if you correctly achieve a proof of work on a block, you're rewarded with a little bit of Bitcoin. Okay. So there's a couple things to notice here, and we're not that bothered about them, right? So like how many zeros do go into the Bitcoin challenge? It changes, right? So it changes periodically. The code takes care of it, and it keeps things hard, right? So that's our goal. We want to keep things hard and sort of difficult to achieve so that we can reward the effort. How do we make sure that there's no Bitcoin inflation and huge supply increase? Well, there's actually a finite amount of Bitcoin. There's only 210 million. In circulation. And the way that's achieved is we have a little bit of geometric division. Yeah, that's the right word. It's been a while since I've taken a math class. And so how that works is every time we have a reward, cut it in half every 210,000 blocks, right? So the graph looks a little bit like this, where we never actually hit 210 million, we just approach it. So there is a finite amount of Bitcoin available in the world. Are there alternatives to proof of work? Yes, we have stuff like proof of stake, and there's other things like that. We're not too bothered with that for today, right? Everybody with me? It's been a while since I've asked something in the chat, so everybody can just say like, yes, this makes sense to me. That'd be great. Or if nobody says anything in the chat, I'll have to assume that I didn't explain it too well. Good so far, very good. Okay, if anybody has any questions, just jump them in the chat, same as always. So we've talked about what is a blockchain, the technology, but what is blockchain? Meaning, what is the space that's gone around here? So when people talk about blockchains, they're not usually talking about the technology. They say, so these slides are unfortunately not going to be distributed, but there will be ways to reinforce your understanding, and I'll talk about those near the end of the presentation. So usually when I tell people I work in blockchain, I don't mean I am inside a computer network and I do mining and stuff, right? So what is blockchain? The space. And so to avoid confusion, we're going to call it Web3. And this is the general term that you're going to hear, especially in the crypto sphere, which is another word for it. So what is Web3? To understand Web3, let's look at Web 1. Does anybody have any ideas on what Web 1 might have been? And a hint is it's the first iteration of the internet, right? So the first web. What does everybody think? Read, very good. Yeah. So I don't think I remember the first version of the internet. I think everybody in this call probably is a little too young for that. So we can kind of conceptualize it as cable television, right? So if we think cable television versus I kind of dropped my cable box, I just used Netflix and YouTube and that sort of thing. Web 1 is cable, so it's mostly read only. We get to view and access the content that certain providers give us, right? So if I want to watch The Good Place, which is a show, tough, I gotta wait till 6 p.m. on a Tuesday night to watch that show. And I don't really have a whole lot of say in there. So it's company focused. There's a couple people choosing what kind of content goes out there. And it's all about ownership. We own this content, we're going to do what we want with it, right? So mostly read only. And so if we transfer this to the real internet, this is like the first early stages of the internet when things started picking up a little bit. We have like a web page where I can view and print images. So I can't necessarily upload my own. Maybe I can, but it's mostly more about reading content, viewing and accessing it. And that's about it, right? Web 2, any ideas? What is Web 2? Anything at all, right? So if Web 1 is kind of basic stuff, where does Web 2 get us? Information was hosted on servers, that's good, right? The web we are now, yes, yeah. So the stage that JavaScript and stuff like that kind of helped us get to, right? This current content creation, yeah, all of these things are correct answers, right? So Web 2, if we think of Web 1 as cable, Web 2 is YouTube, right? So we can not only access content, we can contribute to the content. And it's more about a community than it is about company ownership. It's more about sharing content, right? So we now have more interactions. The cool parts about this are, so if you think like an encyclopedia and a textbook, we just access the content versus Wikipedia. We now have a say in what goes on there. So it's more community focused. So this is great. And if we think about Facebook before Meta or Twitter without space is good. Yeah. So Facebook is making this change. I'll talk a little bit about that later, probably. But yeah, great answer. So it's a lot cooler, right? We have more interaction. We have more stuff we can do with the internet. If you think about phones in your pocket nowadays, how much can be done with location services? The fact that I'm able to use Google Maps when I'm driving, and it can tell me that there's an accident ahead of me. And the police can't tell me that, but Google can tell me that because it notices that a lot of phones are in a close proximity to each other, right? That's very cool. So it's like location services, it's everything that JavaScript and new mobile applications have sort of enabled for us, right? Here's an issue, right? The Web 2 space is awesome, and it's fantastic, and it's worked very well for us, but it is centralized. So without naming the companies themselves, we can say that there are a handful of companies that sort of own the majority of the internet, that are driving the most traffic. And consequently, they also own most of the data on the internet. So they own everything. It might be about sharing content, but our data and our content is owned by somebody else, right? So how can we do this? So what is Web 3? This might be the last time that I give out a guess because we're running short on time. But what might Web 3 be then? Decentralized web, very good. So Web 3 is what we have now because of blockchain, right? So Web 3 is in the works. So it's portable and personal. It's individual focused. What that means is not everybody's selfish, but everybody is able to operate as their own individual entity. You don't need other people. You can contribute yourself and be valued for your work and own everything you put on there. So what you're seeing on the left, it's a blockchain project called Library. So it's a lot like YouTube, except everything is run on the blockchain. So you have your copyright on the blockchain, your ownership is better, right? Because we can very specifically say, yes, I own that video, I created it, and it's better compensation for users, right? So not only can we say, I own this, compensate me for it, and I have more say over that, we also have a lot more possibility with tokenization, right? So we have new values, new modes of valuation, and a lot of cool things come out of this, right? Big thing is it's decentralized, right? The power has moved from a few centralized entities into everybody. Anybody can be a large sayer in this sort of network. Okay, so that is Web 3. If we look at a definition, everything in Web 3 that we're going to see this space either solves blockchain's problems, meaning like we looked at a couple problems with Bitcoin and like it uses a lot of power, for example. So it's not a perfect system. So everything in Web 3 is going to solve a problem, or maybe it solves a problem of one of the solutions, it just keeps going, or it explores its possibilities, or maybe a little bit of both, right? This is what Web 3 is. It's both of these things. It's everything stemming from the original blockchain. So if we look at some possibility, some problems first, right? For example, Bitcoin is quite slow. It's 5 transactions per second. For reference, Chase, the credit card, does up to 10,000 transactions per second. So it's a cool system, but it might not be ready for adoption if it's so slow. So something we talked about in our Intro to Polygon event a couple of weeks ago is how Polygon can actually push up to almost 10,000 transactions per second, which sort of rivals Chase's capability there. So we're fixing up problems here and there. And that's something we talked about during our talk. Another problem is something I've mentioned, is that proof of work uses a lot of energy. So you're going to need a lot of equipment that costs, right? There's also a financial barrier there. Like not everybody can buy that amount of equipment necessarily. It's also not great for the environment. There's costs of energy, and that has ramifications for the environment. Probably not the best, right? So something we talked about in our technical workshop with Nir last month was, what if we used an alternative, mechanism? What if we use thresholded proof of stake? So it's not important what that is, TPOS. You can always learn about it later, but it's just to give you an idea that projects in this space are solving the problems that originated with this original one, right? So everything in Web3 solves blockchain problems, and it also explores its possibilities. Does anybody have, this is a chat, I'm gonna let you guys do it anyway. Possibilities. What are the possibilities of Web3? So we talked about library and decentralized ownership of video content and new modes of valuation. Does anybody have any other ideas? What can we do with this? Mobile first. Yeah. Yeah. Blockchain. Yeah, so blockchain is going to facilitate something for ourselves. We're going to have better identity ownership. Fantastic. Yeah, so something I haven't put in the, mobile first blockchains. I'll talk about identity verification. That's like a big one. So a lot of blockchain projects have put passports and licenses onto the blockchain. And so we're able to see like, yes, this is an authentic document. So that's a very common use case. I'm going to talk about three big ones here. So the first one we're talking about is decentralized finance. So you don't need to be a finance buff for this, but you've probably had some experience with this yourself. Our financial system relies on opaque systems of intermediaries, which means banks, brokers, escrow, if you know what that is, people we have to go through that drive costs, and they're potentially untrustworthy. So why do we have intermediaries? Well, we need to trust each other, right? If I'm transacting with somebody who I've never met on another country, another continent, I kind of need some safeguards in place to make sure that that transaction goes well, because I'd love to trust them, but we got to be realistic, right? But that costs. We have humans who are in place, and we have humans to design those systems. They're potentially untrustworthy. So not to make any big accusations, but we do know about 2008 and a recession that was caused by a few central entities sort of doing stuff that they shouldn't have been doing. And the stuff is opaque, right? So when we centralize the power between a few people, it's tough to see what's going on. And this is not a transparent thing. So what can we do? Like, what if we had a trustless mechanism by which transactions could be permanently and transparently recorded, and we didn't need these costly intermediaries? What if we did? Do we? Yes, we do. So blockchain lets us do that. So something we talked about in our Hack DeFi, which is a big hackathon that we did with Wintermute, we can move from costly third parties that require trust over to no third parties or trust required, right? So this is what DeFi means, decentralized finance. So you probably heard that term. This is all it is. It's using blockchain to facilitate these trustless, decentralized transactions. Let's look at another possibility. Non-fungible tokens. So non-fungible, that word means we can't take it away. It's sort of permanent, right? Immutable in a sense. So if you look at the current scope, with theft, asset creators and purchasers, so people who make assets and people who buy them off of that, the creators, they can suffer non-compensation for usage of their work and disputes as to the asset's ownership. So a big example of this, if anybody's like very into YouTube, a lot of my favorite YouTube creators complain about copyright strikes on stuff that should not have been copyright striked, and it's very tough for them to fight those claims, right? So there's disputes as to the asset's ownership. Another thing is if we start talking about digital collectibles, so if we move from physical baseball cards into digital baseball cards, let's say, it's very easy for me to go on somebody's work and copy paste it and just sort of use it myself, right? So how can I control, right? How can I say after I've made something and put it out and sort of proliferated throughout the internet, how can I then say, actually guys, that's mine. I created that. I want to be compensated for it. Do we have a way of doing that? What if we had tokens that allowed for clear ownership records so we know who created something and we have a clear audit trail? And it also introduced new means of valuation, new ways that we could compensate creators and people who own the assets. What if we did? Good thing we do now. So something we talked about in our NFT hack with Filecoin. So we did a whole educational series about NFTs, technical stuff, and then moved into a hackathon, is that we can now move from poor ownership records of assets and compensation into NFTs. This is the thing you've definitely heard about. And these are new ways to accurately track ownership and compensate our creators. So it's pretty cool. I think I've got one more possibility we'll talk about. So Now we're going to talk about decentralized autonomous organizations. That's a huge, huge word. Don't let it, I mean, you're pros now. You shouldn't let that scare you. So the governance, meaning the decision-making of a few powerful institutions, are concentrated between a few people. So if we think big companies, governments, right? It's a few people calling the shots, right? But this is kind of a problem because decision-making is concentrated in a few people. That's not necessarily fair. It's shielded from stakeholders, so we don't know how they're arriving to those decisions, and sometimes we don't even know the decisions themselves. And they can be compromised, right? So if we have a few people, they can cross their heart, hope to die that they're not going to let their personal interests sway the decision. But realistically, we don't know. That's the thing. There's an element of trust, and that's what we're trying to get rid of here, that we don't need to trust anybody, that we can check them. So what if, hypothetically, we had a transparent and decentralized way by which decisions could be made, so better governance, and governance token could incentivize participation by stakeholders, meaning regardless of the decision you make, we're not bothered, right? If you should vote yes or no on something, just by participating, we encourage that. We want everybody to have a say, regardless of what that say is. What if we had that sort of system? Good thing we do. So something we talked about in our intro to DAOs last month, and we work with BitDAO quite a bit, is that we're moving over from these concentrated, compromised, and opaque governance systems and more into DAOs, which is something you might have heard about. DAOs is decentralized autonomous organizations. These are transparent, decentralized, and we have motivated stakeholder governance. We have a way of encouraging people to participate, which is fantastic. So there's been quite a few use cases of this. Let's talk about some other possibilities. So let's say currently you are somebody who's like, you've liked what you've heard in this talk and you want to keep learning about Web3, but Web3 is quite new. It might be the first time that you're hearing about this today. So it's quite new and information is sort of fragmented and there's a lot of people talking about it. So it's not always reliable. So what if, hypothetically, there was a place where non-technical people who are interested in tech, like myself, and developers who are interested in the ins and outs of Web3, maybe they want to start coding on it, could receive live, meaning questions are answered and it's great, virtual, so you don't necessarily have to be anywhere, and free, no financial impediment content delivered by experts. So experts, you know what they're saying is right. What if we had that? Does anybody have a guess as to my answer for that? Nobody wants to play along. Well, yes, we do. And so this is kind of what Encode provides to people. We have education, which is technical and conceptual. We have boot camps where we have very small cohorts with intimate support, and we help those people get jobs directly after the boot camp. We have AMAs with the top CEOs and people working in the space who are deeply involved in it. So we're moving from, yes, you do, yeah. There you go. So we've got fragmented and unreliable Web3 education. And through Encode, we're able to move to live, free, virtual, and expert-delivered AMAs, workshops, and boot camps. Everything is free. I cannot emphasize that enough. So it's very accessible, this stuff. Let's look at another one, and I won't do too many of these. We'll do a few. Let's say now you know a lot. You don't have to be a technical person to build something. I've been involved in so many hackathons. You don't necessarily have to be a technical person. You just have to be able to work with them. And if you're a developer, this is sort of your bread and butter. I will be sending links at the end of this. And actually, you can follow the form that I sent in the beginning, and I'll be putting that slide up again, so don't worry. So let's say you want to build a Web3 project, but hackathon projects or the periods, they're kind of quick, like they're usually a weekend or a couple weeks. They might be subject limited, so something that you don't really care about or you're not interested in, and you don't always know enough to participate. So that's a big intimidation factor. So what if we had longer hacks that ran from 6 to 10 or even 12 weeks? We did these on many topics, right? What if we taught the protocol, the potential, how to use it, basically everything that you need, all before building even starts, and you have support from that protocol and from the Encode community and basically everything that you need to help build an awesome project? What if you did? I'm not going to torture you guys. We do. So we can move from our hackathons, which are 6 to 12 weeks, and they're awesome ways to earn tokens, internships, and cash. They're also just really great ways to network and start building your career capital that way. We can move from short, low info, and sort of limited subject hackathons into longer and flexible educate hackathons. So we teach everything before you even get there. So we won't teach you how to code, but we will teach you, if you already know how to code, we'll teach you how to code on that platform specifically. And if you're a non-technical person, you'll know pretty much the ins and out of this platform, and you'll know where to look if you need more information. So longer and flexible educate hackathons on a variety of topics, which is really fun. So two more, not too many. Let's say you've got a Web3 startup and it's difficult to scale your project or find feedback from experts and secure investor funding. This is hard for any startup, but Web3, since it's very new, right? So this can be even tougher. So what if we had a Web3 startup accelerator, an investment program integrated into the hackathon? So let's say you have an awesome hackathon idea. So you put it through the hackathon, you have time to build that up and sort of think about it, refine it. And what if you had an accelerator that was directly connected to that hackathon? So you could build your project and automatically apply for an accelerator and be considered to go through that process and get investment for it. Well, good thing we do. So we've got our accelerator, which is a 10-week program that turns startups into proper companies, and we give startups basically everything that they need, which is funding, classes, and connections. We also do investment, which is backing by leading angels and venture capitalists for advice and for funding. So going from an idea that you might have or an interest that you might have in a crypto topic to building it in the hackathons to making it to a proper company in the accelerator, and then taking things to the next level with the investment. So it's quite a nice funnel. And through that, we can move from little support for Web3 startups into integrated accelerate and investment opportunities for Web3 startups. Last one, and this is probably the one that's most interesting. So Web2 and other professional paths, so if you think banking, finance, law, they've sort of begun to reach a limit in their progression, availability, and innovation. They're still awesome careers, but more competitive. It might be sort of hard for you to reach the level that you want to. Their availability, because there's only so many spots, and innovation, right? Even if you reach that top level, it might be great, but you're not really doing too much new, right? The frontier has been explored, we're done. So what if non-technical and technical people, so both sides, had a ton of new opportunities to innovate? And what if they had a place to find those opportunities? What if? Anybody have an idea? Just because it's the last one, it'd be nice, nice to indulge me. Well, we do, right? And so this is the final part of yes, it is possible. So our talent wing has exclusive technical and non-technical jobs. And when I say jobs, I mean any kind of work placement. So for student, yes, there is. So for students, they're usually interested in co-ops and internships and that sort of thing. So work across the spectrum. So by being involved in our network, building hackathons, or like being involved in the events, you're automatically considered for these, and you can talk to us. You can apply to talk to us to get a little more intimate support. And so through that, we're able to move from stagnant professional paths over to Encode, which does recruitment for non-technical and technical positions throughout Web3. So there's a lot there. There's a lot of opportunities here. If you like what you've heard in this talk, what can you do? There's that form I showed in the beginning. So you can take your phones, you can scan the QR. I'll also punch that link into the chat. And so that's going to take you to a form that sort of asks you, who are you? Tell us about yourself. A lot of it's optional, but I encourage you to fill out as much as you're comfortable with because it helps us out a lot and helps with the job stuff. And so you have the option of signing up to our mailing list, and so that you know when we're running these events and all these programs. You also have the opportunity to apply for a call. So we can't meet with everybody, but we'd love to talk to a few people just to understand your goals and see how we can get you there. So by following that link, that's sort of your gateway through. At the end of that form is a bunch of links that takes you to everything that we do. So our YouTube channel that has all of our recordings of past events, our Telegram channel where we post everything that's happening the next week, our Eventbrite where you can sign up for these events and see what's coming up in a month or two, our Medium, our Twitter, everything else. That is all in the form. So you'll have all the resources you need there. And that's it. That's it from me. So I hope by the end of this, you've had a very good understanding of all these different things. What is Encode? What is a blockchain? What is blockchain, the space? And how does Encode help you get to where you want to be? So I can do about, so went kind of over time, so I can do about 5 minutes, maybe a couple minutes of Q&A. But if you guys have any questions, please just punch them in the chat. Anything you'd like me to explain a little better that you didn't get the first time, just go ahead in the chat. Thanks for being informative. No problem. Yeah, I hope that everybody has a great understanding of everything that we talked about, and I hope to see you at some Encode events. Sandra, any questions? Anything? Okay, so what happens when someone pays you twice? That's a good one. So if we look back, where did I put it? Here we go. So remember that every transaction, when we implement the unique transaction IDs, even if, let's say I'm paying Beaumont, right? And I want to pay him twice. That's actually what I want to do. That's okay, because we treat this as a totally different input, right? So with the totally different input, the signature is going to be completely different. So yes, they're paying you twice, and they might pay you a separate, an identical amount. Yes, I don't think I'm the host, Sandra, unless I am. Wait, I'll check. I am the co-host. Okay, yeah, Sandra, let me give that to you. Strange. Can't unmute your mic. Okay, just a sec. Okay, yeah, I think it would have to be the Apps Lab KE to do that. So I'm not able to make you host, unfortunately. But if the Apps Lab, whoever that is, could make Sandra host, that'd be great. So as I was saying, the transaction has a unique ID associated with it, right? So this is a totally different thing to this. So in our terms, yes, these are identical transactions, but as far as the code and the network is concerned, these are two completely different things. I hope that answers your question, Jordan. Good. Anybody have any other questions? And you can ask about other stuff. It doesn't have to be something. I'll try. I'll try to answer it as best as I can. Just something else in this space, or about Encode's opportunities, or anything like that. Just one thing about the form is, if you guys could, where it says organization, say which DSC you came from, or whatever organization you're from, or it's like college society, that'd be really great, because it helps us plan for our future events and all that. Okay. Yes, Sandra, I'm sorry, I can't make you host for some reason, so it'd have to be the apps user. I tried applying for an accelerator, but I wasn't successful, but I had a cool project idea. That's totally cool. So unfortunately, not everybody can make it in. It's sort of a funnel that condenses over time. But I definitely encourage you to try to talk to people on the Encode team. So like maybe we can go through it together sometime. Sandra, you're co-host again, so you should be able to unmute yourself. So yeah, Lungash says he applied for an accelerator, wasn't successful. That's totally okay. You can always try for an accelerator in the future. And it might have been that your project might have been great and it just was a capacity thing. But I encourage you to apply, to talk to us. We can talk through your project, and maybe there's stuff we can tweak about it to make it a little better and push it through the accelerator. So I definitely encourage you to keep trying and keep working. Sandra, I think you can unmute now, hopefully.
Oh yeah, I can. Yeah, that was a lovely session. I really enjoyed it.
Great, I'm glad. Yeah, I hope this was very useful for everybody. Yeah. Okay, so I'll give it another minute just to see if there are any questions. We'll also bring the slides over to that QR that I showed you. So if you liked what you heard and you want to keep learning, or you want to get into our jobs funnel or the building or the hackathons or anything else I talked about, this is your chance. So you can scan that QR code or you can follow the link. When we'll be able to receive our copies of this recorded session, I think that will be up to Sandra and Clifford. I'll let you guys handle the distribution of that. So Sandra, I'm guessing if you're in one of the WhatsApp groups or something, they'll handle that.
So yeah, since it's going to be recorded, we're gonna have the recording posted in the WhatsApp groups.
Good. Okay, guys. So if there's no other questions, please feel free to go through that form if you want to get in touch with us. In the case of digital marketing, what opportunities are there in blockchain? Plenty. So, gosh, there's so much. So Encode itself, if we talk about traditional design, right, there's a lot of Web2 sort of opportunities that emerge around Web3. So for example, we're a Web3 company, but we still need somebody to do Java and WebScript and everything like that. So if you are a digital marketer, you're still going to do that sort of stuff for Web3 protocols. So that's sort of the traditional digital marketing idea. In terms of Web3 digital marketing, you might be an NFT creator, you might manage or like portfolios. So if we think about like OpenSea, this is a great NFT marketplace. And no, is it open? Okay, well, if you visit this on your own and your computer isn't slow like mine, you'll see there's a ton of NFTs here. There's so much around it. You can kind of see them here. Right, great digital artwork. So digital marketing can go in the Web3 direction here, but every Web3 company is going to need people to do digital marketing for them. So yeah, you can kind of go either way about it. You can be a Web3 digital marketer, or you can be digital marketing in the traditional sense for a Web3 company. I hope that answers your question. Great. Okay, so I'm going to tie it off there. Thank you for having me, guys, Sandra, and I'm not sure if Clifford made it back, but this is a fantastic session. I loved how involved in the chat everybody was. I really appreciated that. Any questions, just go through the form and we'll be in touch. I hope that the resources are helpful and useful for you guys, and I hope this is a great session, and I'll kind of leave it there. Okay. Yeah, everybody take care, and that's it. Okay, let's stop sharing my screen and I'm going to take off. Okay, bye-bye everyone.